and get started. It is day 11 in Algebra 2, and it is Wednesday, October 22nd. October is flying by. Every day goes faster, I feel like. It's crazy. So for your do now today, I gave you 3 parabolas, and I wanted you guys to identify the key features that are listed below. So your direction of opening, your vertex, your axis of symmetry, your zeros or your x-intercepts, and then your y-intercept. And then after that, I gave you 1 quadratic equation to try to solve using the quadratic formula. So if you didn't get to this part yet, that's okay. We'll go over it together. But we're just going to review a little bit of the parabolas from yesterday, and then we're going to go back to messing around with the equations just to make sure that we feel good about it. So let's look here at the first parabola for number 1. Zoom in on that. So, first, direction of opening. What would that be? Down. My arrows are pointing down, so that is our direction. Now, does anybody know what my vertex would be? -3, -2. You're very close. -3 is correct. 2. So I think anytime that I write the tick marks, I have lots of people accidentally confuse that for a negative. Just remember that if it is above the x-axis, it's a positive number. If it's below, it's negative. Easy mistake to make, so don't worry about it. So this was our vertex. To find our x value, just real quick, we just trace down until we touch the x-axis and we see, oh, it lines up with -3. So that is our x value of the vertex. And then we could trace over to the y-axis and it lines up with +2. So that's our y value. Okay, so there's our vertex, -3, +2. Now, the axis of symmetry is what I want next. What will the axis of symmetry always be the same as? Yes, it's going to match the x of the vertex. So if my vertex's x value is -3, my axis of symmetry is -3 because it goes through the vertex. And I'll draw that up here. Here's my vertex. My axis of symmetry goes right through it here. Let's label that x equals -3 because we're passing through -3 on the x-axis. Okay, so now we want to identify any of our zeros for our x-intercepts.
-5, -1.
Yes, -5 is an x-intercept, -1 is an x-intercept. Now, whenever I write my x-intercepts, what should I not do?
Put parentheses.
Parentheses. A few of you may see a note. Yes, if you write -5, -1 in parentheses, you're telling me a coordinate. -5, -1 would be right here, this little point. You don't want to do that. No parentheses. You have 2 options. I can either write x equals -5, -1 with no grouping symbols, or I can use these little fancy brackets, the little squigglies, and write -5, -1, but no parentheses. No parentheses. Okay. Last but not least, we need to identify the y-intercept. Where is that?
-3.
-3. Good. right
Yeah, I put it in the
here.
wrong place again.
What'd you say, Diane?
I said I put it in the wrong place again. The vertex and the zero.
The vertex and the zeros.
Oh boy.
So something that I think can help, bless you, with remembering what the vertex is versus the zeros is I like to think of the vertex being the point that makes the almost V shape. Vertex, this is the point where it's like the V. Even though it's more of a U, it's kind of like a V. So like the vertex of the next one is always going to be that point that makes it a V shape. So that may help just to think of it as the shape. So our y-intercept, I didn't write that, but it is right here, is y equals -3. Now, of course, you could do this that I'm about to show you for the y-intercept or even the x-intercepts. I saw one student wrote it as a coordinate, which you can do as long as you're writing the correct numbers. So, for example, this is the y-intercept. It's at -3 on the y-axis. That would mean that my y value is -3. What would my x value be? 0. So you could also write 0, -3. Because x is 0, y is -3. So you can do it that way too. Now, if you do parentheses for your x-intercepts, you would need 0 in the y value place. So we would have -5, 0 and -1, 0 in parentheses. If writing them as coordinates seems to get you a little bit mixed up, though, don't worry about it. Just as long as you can tell me the number, I'm happy with that.
So, sorry.
No, go ahead.
We can't use the bracket for the negative. Well, never mind. No.
No, go ahead, because your question actually may help someone else in the room, even though you might be answering it in your head.
That's
What were
because
you
you
gonna
just
ask?
said it was a coordinate, so that's why you put the parentheses.
Mhm.
This the bracket, like you said, that's showing it different instead of it being a coordinate.
Yes. So let me make a note of what you kind of just clarified there. I'll do it on a sticky note because this is an important thing to know. Anytime that you put two numbers in parentheses, like a number here and a comma and another number, this means an ordered pair. This is a coordinate, meaning it's an x value and a y value. So this is a coordinate with x and y. If I use brackets like this with numbers, this is not a coordinate. This would be single values. And it's usually just x values. How we refer to x values. Now, of course, you could also say x equals number. These are also single values, not coordinates. So in general, if you ever put a set of parentheses, that is a coordinate. So if you're not referring to a specific one single point coordinate, do not use parentheses. We always want to use brackets or just say x equals or y equals. Does that help kind of clarify when you're supposed to use it and not?
Mm-hmm.
Okay, good. So I'll leave that up for a second in case anybody wants to write it down.
You explain things so nice. I wish you were like my Alexa voice or something. I could be like, Miss Taylor, could you please help me figure this out? Yes. Here I am.
Oh, I'm so glad that it helps. I just know whenever I was in high school and I didn't quite understand something, I was not a fan of when the teacher would just get mad at you for not knowing or not understanding. But, this is my job. When you don't understand something, I want you to feel safe enough to tell me that because it's my job to explain it to you.
Yeah, all of you guys here are like so good at, even if it's a question that everybody would seem to know, like so good at just not making somebody feel like that was a question that somebody already should have known.
Right.
So it's like it could have
right.
been like something simple like what's 2 plus 2, and you
Right.
like get elaborate into it like this equals this and this and this, and I'm like yes, I love it. It makes me want to go into human services. I watch you guys and it's
You're gonna be so good at that. Thank you. I love it. I'm gonna pause this while I still see a few people writing, and then we'll move on to the next one. Okay, so I'm gonna move this to the side, and let's look at the second parabola now. So, first feature, is it an open direction? Open. Is the direction of opening up or down? It's up this time. My arrows point up. So we're pointing up. Now my vertex. What is the x value of my vertex?
-6 and +2.
Ooh, yes, the numbers are correct, but flipped around. So first, what I like to do is look for the vertex. That's that V point right here. And then to find the x value, we want to just trace up until we hit the x-axis, and that too is correct. Just make sure the x value comes first.
Gotcha.
Sylvia always says as a baby you walk in and you stand, so we would walk over to the 2 and either stand up to 3 or like go down
Right.
to 6.
That is
That's to
smart.
explain it.
I like that.
She explains things so weird and it helps so much.
Right. She cracks me up.
When you said stand up to 2.
So like when you're a baby, the first thing you do is you crawl. So you're crawling and that's the X. So you go over 1, 2, 3, you're crawling 2, 3, you could say, and then you would stand. So you could stand and the y-axis is stand, so you go up to 3. So you walk and then you stand.
So here, I'll explain it in context of this. If you're wanting to understand this analogy, we're thinking of it this way. Our starting point is 0. When you're first born, you're not any years old. You're 0. You're a newborn. You're fresh. And before you can start jumping up and down and running around and things, you're going to crawl. So you're going to be going either forward when you crawl or backward when you crawl. That's the x-axis. So my vertex, to get to the same position, we crawled 2 spaces.
Yeah.
Now we're lined up. So there's my x value. We crawl first. And then you could think of it as I'm going to stand up and try to walk. Or when I stand up, I may fall down. And we can see that when we fall down, we go to -6, which is our y value. So little silly tricks can help. I like that.
Diane, we like those in Sylvia's class too.
Yeah.
He's got all kinds of.
I know I made
Silly
one with
tricks.
the whenever it has like a slash through it, it's
Uh-huh.
married or some analogy. Yeah, I'm gonna use this forever.
Married or cheating.
It's married or cheating, yep.
Yes.
Tie down.
One of these days, I need to have her like really sit and teach me all her analogies.
Yes, it's very
Funny.
helpful. Both you guys can learn so much from
Right. Okay, so we have our vertex. How can this help me find the axis of symmetry? It's the same as the x value. The axis of symmetry goes through the vertex. So whenever I draw my little dotted line, look, it goes through 2 on the x-axis. So x is 2. And it matches the x value of the vertex. That will always be the same number. If it helps you to remember, draw some kind of little symbol to show that these will be the same.
Yes.
Maybe circle it and draw an arrow. Same. This will never be different. These will
Oh, wow.
always be the
Wow.
same.
You said that the other day, yesterday.
Yes. Always the same. Okay, so we've got our axis of symmetry. Now let's find our zeros, our x-intercepts. So let's look at the x-axis. And where do we touch it?
-2 and +6.
Oh, I'm looking at the wrong graph. Yes, -2, +6.
And I got it right.
Good. So I can write x equals -2, comma, +6. How else could I write this?
In the bracket, or you could do -6. -6 and +2.
Okay, hang on. Let me put the brackets first. So we can either do x equals -2, comma, +6, or we can do in brackets -2, comma, +6. We cannot put it in parentheses because that is a coordinate. We're not naming a coordinate, we're naming 2 points. So if we wanted to use coordinates, we would have to say our x values first because x comes first and then y. So what would my coordinate be for this point at x is -2?
-2, 0.
Yes, -2, comma, 0,
Like it.
and
You could put it in.
6,
Okay.
6,
0.
comma, 0. Yes, 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 yes. So you have 3 different options for writing your x-intercepts and your zeros. If the coordinates feel like too many things to remember, it's fine. So I'm going to circle all 3. You can do any of them. You don't have to do all of them. You just have to pick one. But do not put -2, comma, 6 in parentheses.
We'll get -5.
Yeah,
Half a point.
you did have a point on that.
And I sure did make that correction to get that half a point back.
Okay, what was my y-intercept? Where do I cross the y-axis?
-5.
-5, right here. So I can say y equals -5, or how else could I write this?
Yeah, 0, -.
Yes, or I could write 0 for x, -5 for y, and it could be a coordinate. Good. Good, good, good.
Got him.
Got it.
Okay.
That's big.
All right, we got just one more after this. Remove this over. Does anyone still need to see this second column before I scooch my paper? Okay, so let's look now at the third parabola. It looks like my arrows got cut off, so I'll just trace over those again real
I was
quick.
going to ask you,
Yes.
if that
Yes.
was use that infinity sign or not.
So because I didn't ask you for the maximum and minimum on either of, or on any 3 of these, you wouldn't have to, but we can absolutely go through and say what would those be because that's going to help you on your bonus later. So we'll go back once we finish this one and we'll see what our max and min would be. So for the last one, is this up or down?
Down.
Down. Vertex.
+6.
Okay, is this my +6, my x or my y?
The X.
Let's see. It's right here, right?
That's why.
That's my y.
Stand
Yes.
Stand up.
Yes. It can be tricky to remember. Tracing over, tracing down. 3 is on the x-axis,
Yes, it is.
and 6 is the y.
Yes, it is.
Yeah. So, what's my axis of symmetry?
+3.
3. Good. X equals 3.
Does it make a difference if I have it in which order?
Do you have 6, comma 3 instead? That does make a difference because 6, 3 would be here. If I start at 0 and I go over 6 on the x-axis and then up 1, 2, 3 on the y-axis, that would mean you're saying this is my vertex.
Oh, okay.
And that's not my vertex.
Oh.
Over 3, up 6, that's my vertex.
Remember, like the alphabet, X comes before Y.
Yes, x comes before y every single time. And something that helps me remember, like, I don't know why, but I always had such a hard time remembering which one is x, which one is y. This is the trick I always used. So I'll show you real quick. It's fast. It may help some of you. I like to remember that the y-axis goes up and down because when I write the letter Y, I can draw a big long tail going down like that. So the y-axis goes up and down. My x-axis I can remember because whenever I draw my little arrow like this, I can turn the end of the arrow into an X. Ah.
That's why you learn something.
Now you say the Y does
Right?
in your brain.
Yeah. So, man, this is what got me through, and I've never forgotten it since I learned this. This helps. So I'll draw that one more time. I'll demonstrate that again. Your y-axis goes up and down because when you draw a Y, you can extend that tail and make it go up and down like that. There's your y-axis. Your x-axis, again, if I draw that little arrow going both ways, I can turn it into an X. X-axis, y-axis. Don't never forget. If it helps, write it down. Write it down if it helps. X goes side to side, Y goes up and down. I'm going to move that to the side and let's finish this last parabola. Now I need to identify my zeros, my x-intercepts. What are those? Good. -1, +7.
That's it.
So this time I'll use brackets. -1, comma, +7. And it doesn't matter which number you write first. Now, if I did want to do coordinates, what would my -1 coordinate be? How would I write that?
-1, 0.
Yes, -1, 0. And my 7? 7, 0. Good. And just remember, since it's the x-intercept, we're writing our number in the x spot. When we're doing a y-intercept coordinate, the number goes in the y spot. And then the other number is just 0 every time.
Oh.
So you can write it either way. I won't require you to make the coordinates, but you can if you want. And then last but not least, I'll zoom back up so we can see it. What's our y-intercept? 4. Good. Right here, we cross 4 on the y-axis. So I can write y equals 4. Or what would my coordinate be?
0, +4.
Yes, 0, +4. Good. Good. That is wonderful. Okay, I will leave this up for anybody still writing. And then in just a moment here, we will move on to number 2, and we'll start solving this quadratic equation. Okay. Can I move my paper? Anybody still need to see this? Okay. All right, so what I am going to do is, because I didn't give us any space for this problem, I wrote you a little note. You may need to work this out on the backside. So that is what we're going to do. I'm just going to copy the problem down so I can bring it to the back. And that is x squared plus 10x plus 24 equals 0. Okay, so flip my paper over. And well, that's gonna bug me. I'm gonna get a separate paper out to work this
It's just like me.
problem because that is going to drive me crazy. Okay. So I will actually go ahead and pull out my notebook and I'll just title that this is our do now problem for day 11. So algebra 2, we're in unit 2. And this isn't notes technically, but let's see. Day 11, 2. Okay. And one more time, our problem is x squared plus 10x plus 24 equals 0. And we want to solve this equation using the quadratic formula. So,
You need a calculator?
say that one more time.
Oh, we're gonna need a calculator?
Yes, if you don't have a calculator yet, go ahead and grab one. You will definitely want a calculator today. And while I have you guys grab calculators,
Anybody need a calculator?
Me,
Uh-huh.
mama.
so sweet.
Mamma mia.
We're gonna copy down the formulas we need. Yes. Day 10 worksheet. Pause. Okay, so before we solve the quadratic equation, let's remind ourselves of a couple of things. First, let's remember the form that this equation is in. We have a quadratic equation written with ax squared plus bx plus c equals 0. So I'm going to move that so that it kind of lines up a little better so we can see how these relate. And then before we actually do use the quadratic equation, I like to break the problem down into 2 steps, where the first step is that we find the discriminant. Does anybody remember what the formula for the discriminant is?
B squared
Yes.
minus 4ac.
Good. B squared minus 4ac. And that's our discriminant. And after we find the discriminant, we plug it in to the quadratic formula, which we'll write the simple version. And that is x equals, what comes next?
X equals negative b plus or minus the square root of
The square root your discriminator, I know that.
Yes. So normally it would be x equals negative b plus or minus the square root of b squared minus 4ac. That's the discriminant. So why don't we just write d? Save ourselves some space. Once we have b, we don't have to do all that again. So negative b plus or minus the square root of the discriminant.
all over 2a.
Yes, all over 2a. Good. So this is the formulas that we will be, or these are the formulas we'll be using. So if you don't have that copied down, this is a great thing to write down. Let me write this again. This formula. Okay, so I will put this over to the side, but I'll make sure that you can still see it, bless you. And the very first thing we want to do is identify A, B, and C. So, what is my value for A?
X2.
X2. So x squared is next to A. So whatever is in front of x squared is A. What's in front of x squared?
Did you add a 1?
A 1. When there's no number in front of your x, that number is 1. So what's A?
1x.
Not x. What's in front of
1 times.
what x squared?
You added 2 times.
So let's see. I just want to know what's A. We have A x squared So this is A. I have 1x squared. What's A? 1. Just the number. Just the number.
Okay.
So we don't include x. We don't include the squared. We just include the number in front of it.
So 1 is A.
A is 1. Yes, 1 is A.
I'm gonna put that over there.
Yes. So we're just labeling right now. So I have my A is 1. What is B?
10x.
Almost. Just 10. Just 10.
10 is B.
Good. 10 is B.
Gotcha.
No X, just 10. Because what will happen is if you do include X, I see this on student work sometimes, that X will come down into your calculations and it'll get things real confused and you don't know what to do with it.
So
Yeah, you're going to think you have to multiply something. We just want the number. No X's.
So can I put the B and A over there right now?
Yes, I like to make a list because this keeps us organized. So A is 1, B is 10. What is C?
B is 10. C would be 24.
24. Good. C is 24.
Yeah.
Okay, so that's the first thing we do is we identify A, B, and C. And I think it is worth the extra 30 seconds it takes to write them out to the side and make yourself a key or a list. This really helps. Okay. So once I know my A, B, and C, the next thing we're going to do is we're going to find the discriminant. So I'm going to copy this formula down, but I'm going to leave blanks. So I'm going to write D equals, I know it's going to be whatever B is, squared minus 4. There's always a minus 4, that's part of the formula, times whatever A is, times whatever C is. So A, C, I'll put that as a little key up there. So what goes in the first blank?
10.
10. Good. 10 is B. So I have 10 squared minus 4 times what goes here? 1 for A times
24.
24. Good.
Okay.
Good.
It does make it easier when you got your key like you just
It
said.
does, doesn't it?
Can I ask you a question?
Yes.
Why did you flip them?
Why did I flip them? What's
Different
flipped?
formula. You're talking about why the B is the 10. Just because it's a different formula. It's a discriminant formula.
And what
So
did
what are
come
you?
up- What did you come up with the -4?
Oh, so it's part of the formula. Remember, it's B squared
I see
minus
it.
4AC. So everything
Oh.
that I've written in gray is the
Okay.
formula. The orange is the numbers that came from the equation, from the problem. So orange is my ABC. Gray is the same for every problem, no matter what. Part of the
So you
formula.
had to line it up like the formula. I see. I
Yes.
see why you did that.
Okay,
It has to be lined up like the formula.
Good.
Gotcha. Okay. I'm ready.
Okay, so we plugged in B, A, and C. So now let's just go from left to right and simplify the numbers. So what am I doing first?
10.
I'm doing
10 squared.
10 squared, which that means, does that mean 10 times 2?
10.
10 times 10. We're taking 10 times itself. So 10 times 10. And what is that?
100.
100. Now, as I simplify parts of my problem, I will always recommend cross out what you're done with. Because you don't want to bring that down on accident. I'm done with 10 squared. I have 100. What's next?
-4 times 1.
Negative 4 times 1.
Is -4.
Okay. And what else do I have?
-24.
Now, is that a negative 24?
-4.
Ah, yes.
-4 times 24 is -96.
There you go. So for these three numbers, the -4 and the 2 you plug in, you can actually multiply those all at once in one step.
Why is it?
Okay.
Why is -4?
Yeah, why is it like? How do I know if it's a negative or a positive? Is that going to be based on what the next number is?
Yes. So to answer that, how do you know if you're going to be like, do you mean how do I know if I'm going to add this to 100 or subtract it from 100?
Because in the formula, it's b either plus or minus, but there's no minus on the first one.
So in the discriminant, we are always doing a -4 here.
Always.
Always. This will
Always.
never change. This is
Okay.
part of the formula. That will always be -4 times A times C. Now, whenever you multiply -4 times 1, oops, here, let me do that again. -4 times 1 times 24. You can type that all at once.
-4 times 1
I just had a different
times 24. Enter.
Yep, when you hit enter, you get
-96.
-96. So since I got a negative number, I bring that down, -96, and that means now I do 100 minus 96. If I had gotten a positive 96, what would I have done different?
You would
Subtract.
add-
I would have added.
Okay.
Yes, we subtract right now because we got a negative. If we get a positive, we would add instead.
100 subtract 5.
So if it was positive, you would have added 96 to both sides.
If it was positive, so like if I had -24, for example, and I did -4 times 1 times -24, then I got positive 96.
Okay.
I would just, instead of bringing down -96, I would have written plus 96.
Okay.
And then I would get 196 for my discriminant instead of 4, like we're about to get here.
Gotcha.
So, just like we said, 100 minus 96 is 4. So I just brought down the equals, brought down 100 minus 96, and again, 100 minus 96 is 4. So the discriminant is 4.
That's right.
Crazy.
So only thing will be with this problem, it will either be a subtraction or addition. Have they?
Yes.
Has it ever been a multiplication or even?
So you'll always multiply these three numbers based off of if you get a negative when you multiply the 3, you subtract at the next step. If you get a positive when you multiply these 3, then you add at the next step. And we'll run through more examples today, so you'll get to see the different things that can happen. So now that I have my discriminant, am I done? Did I solve for all my x values?
Are you?
You still gotta find them.
Yeah, we still need to find our x values, which won't take us too long because we've done half of the work by doing the discriminant first. So now let's use the quadratic formula, which is x equals, and I'm not going to write my letters, I'm going to leave spaces. Negative b, a space for b, plus or minus the square root.
That's I was flipping the equations. That's why I was like, where'd the 4 come from?
Okay, good. I'm glad you figured it out. So we have negative b plus or minus the square root of the discriminant. So all over 2a.
It's been stuck in my head.
It helped. Okay, boy. And if it helps you to write above the blanks what you're plugging in, you can do that too.
Interesting.
So remember, everything that I have written is part of the formula, meaning every time you use this formula, all of these symbols must be included. Every single number, that 2 will always be there. The plus or minus will always be there. The negative in front of the B will always be there. It's part of the formula. So now that I have my quadratic formula written out with blanks, what am I going to fill the blanks in with? What goes in the first blank?
Well, 10.
10. Good. We go back up to our list. B is 10. Plus or minus the square root of the discriminant. What goes there? 4. We just found that. Good.
So D is 4.
B is 4.
Oh, the
Whenever we
answer.
did 100 minus 96, that gave us our discriminant, 4. And that goes, if it helps, you can draw a little arrow. That goes here. And then what goes in the spot for A at the bottom? 1. A is 1 still. Okay. Let's do the math. All right, so now we need to simplify and see what we can do. So, again, we'll start from left to right, top to bottom. First, I'm going to look at negative parentheses 10. If I don't need any parentheses, we can get rid of them at this step. Can I get rid of any parentheses or simplify anything here?
The 2 on the bottom would be 2. I know that for sure.
Yes, we know for sure that 2 times 1 will just be 2.
But you take the negative 10 and multiply it by 4.
So we have negative 10, and then there's a plus or minus
Yes.
the square root of 4. Let's look at one little item at a time. I'm going to cover up the rest. We have the bottom we're not going to do yet.
Okay.
After the plus and minus, we're not going to do yet. Right now, I just have x equals negative parentheses 10 parentheses. Do I need those parentheses now that I've plugged everything in? No, there's no more operations being done. Really what's happening is it's like we have negative 1 times 10.
I was wondering, did you add a 1?
Yeah, or we're distributing a negative. So if B starts as a positive number, 10, at the next step, this makes it negative 10. So I'm going to bring down negative 10 right here.
So you could have added a 1 to the negative?
You can do that. If that helps, put a 1 there. Negative 1 times 10. So x equals negative 10.
Okay.
And then I'm going to cross that out because I'm done with it. I already brought down negative 10. Next, I move forward and I see the next symbol I have is plus or minus. Let's bring that down. Plus or minus. What's after the plus or minus?
4.
4.
4.
The square root of
Square root of 4. Good. So what is the square root of 4?
2.
2. And if you forgot how to do that, I'll review one more time with you. Remember, on your calculator, you just hit the second button and then the x squared button, which is right diagonal from the 7. And that will make your square root symbol pop up on your screen.
You put in the 4?
Yep, then we put in the 4. Enter. Square root of 4
2.
is 2. So I don't need the square root of 4 anymore because the square root of 4 is 2. We're going to bring that down in the same position, right next to plus or minus. We following so far? We see where everything came from? Negative 10 plus or minus. Square root of 4 is 2. I'm going to bring down that big division sign. And then, Charles, you said a minute ago that 2 times 1 is just 2. So I can cross that out. And instead of 2 times 1, I'm just going to write 2. Do we see how we got to this point? Good. Good. Okay. So once we've simplified the 3 items here, remember there's always 3 things to simplify. Your negative b, your square root of the discriminant, and then your 2 times a. We brought them down, and now what could we do here?
What?
Not yet.
How do you figure out which way to go? Like, how do you, the plus and the negative?
So, how do you figure out which way to go? Are we going to use plus or minus? Both. Every single time you're going to use both. That's how we get 2 answers for x. So, when I say that, I know what? I'm going to show you what I mean. So, I have a plus and I have a minus. We always do both. Once we've simplified to having 3 numbers, we split the problem into 2. So I'm going to bring a plus version, a plus version of the problem over, and a minus version. What? I know, it's pretty crazy. And so whenever we bring this down, we're not going to change any of the numbers, but we're only going to write the plus sign for the first one, and we're only going to write the minus sign for the next one. So I'm bringing down negative 10 plus 2.
Negative 8.
Divided by 2.
Oh,
We're bringing the whole problem down. Then for your minus, what am I going to write here?
negative 12.
You will, yes.
Oh,
But we're writing,
Negative 10 minus 2.
yes, negative 10 minus 2
Over 2.
over 2. So now we're solving 2 separate problems. When we have a fraction or that divided by 2 on the bottom, we want to do that last. So first, Diane, you actually told me the answer just a minute ago. What's negative 10 plus 2?
Negative 8.
Negative 8. So I'll cross that out. We did that and got negative 8.
Then negative 12.
And before we go back to the negative 1 or the minus 1, we still have 2 at the bottom. We did negative 10 plus 2. We got negative 8. But remember, it's all over 2a. So all over 2. So now what?
8.
Negative 8 by 2.
Yes, negative 8 divided by 2 is
Negative 4.
negative 4.
Wow.
And now we're done. We figured it out. We got it all the way down to one single number. And now we just do the minus problem. We're almost there.
Almost.
Almost.
Jesus.
So, negative 10 minus 2, somebody said it.
Negative 12.
Yes, negative 12
Divided by 2.
divided by 2. Thank you. Which is
Negative 6.
negative 6. And what you just found are the zeros, the x-intercepts. You just found them on a parabola. The x-intercepts that we identify, where we put them in brackets or we write x equals the 2 numbers, that's what you just solved for. So we have 2 different ways we could write this. I could write x equals negative 4, comma, -6. You could do that. You could also put them in brackets. Bracket -4, comma, -6. Can I put these in parentheses?
No.
No.
Why not?
Unless you're making them a coordinate, because these are both x values. And remember, Diane, we talked about this little sticky note here, where if it's in parentheses, it's a coordinate. It's an x and a
Oh,
y.
and that's not a coordinate.
But for single values, we either need brackets or we need the x equals the two numbers. No parentheses.
So these are considered as single values?
Yes, these are just x values. We don't have x and y, just x. Okay. All right,
Can you
guys.
call them parabolas?
Parabola.
I know.
Parabola. Oh, here, hand it to me. I might have some batteries
Was one of them.
somewhere. Thank you. Wow. I'll see in a minute. I'm gonna get a different copy.
You did. You know what? When I was in Wisconsin, I accidentally got on this, and the only reason I knew I wasn't in the right place, I heard
You heard.
Patel's voice.
Oh.
Yes, she was in class, and you all were doing this, and I said, I'm in the wrong class.
Oh.
Did Patel do this already?
I don't know. I'm not sure who you're talking about.
She's the African girl with the blonde hair with the braids with the twists.
I don't know if I've had her or not.
Oh, well, I heard her voice in your class.
That's funny.
And I was like, wait,
That's
who
funny.
is that?
Okay, guys, that is our due now. I know we kind of took our sweet time with it, but I think it was a good discussion, and I feel like we hit a lot of good points. So we are gonna go ahead and take our break. It is 10:20 just about. So we will come back and probably start up again around 10:35. And we will take some notes and do some more practice with this. But for now, you guys just take a break, enjoy some time, do whatever you need to do, and I'll see you back around 10:35. So again, we are back from our break, and I am pulling out my notebook, and I'm just gonna title our note page today. Algebra 2. Unit 2. And today is day 11, so these will be our day 11 notes. Again, it is Wednesday, October 22nd, so I'm going to write that here on the side. Wednesday, October 22nd. And this will be page 1, my notes. Okay. Now, I'm just going to keep that through. Let's see. On day 9, the day I was not here, you guys watched a video that was titled the Day 5 video. On that day, I believe I had you guys take some notes for how to solve a quadratic equation using the quadratic formula and the discriminant, but I'm thinking today I would like for us to kind of make a revised guide to help us go through these problems and just make a neater version of that little guide today. This way you'll have something to look back at, especially whenever you're solving problems on a quiz. And this would be a great page to bookmark. So let's write how to solve a quadratic equation. And we're going to start by writing 3 simple steps, and then we're going to break those steps down. So, step 1 is to identify your values for A, B, and C. I'm going to use some highlighters today. I am thinking let's use purple, pink, and green. Those colors are pretty different. Brought some extra highlighters into here. There should be some kind of sprinkled around the room. So if you don't have colors that you would like at your table, you're welcome to look around and see if other tables have colors you can kind of borrow from. It's not going to be everywhere. So I'll make my A purple. I'll make my B green. So we've got some separation in color. And my C will be pink. And right under step 1, we're going to write the kind of standard form of a quadratic equation and highlight those letters. And that is our A x squared plus bx plus c equals 0. And I'm going to just highlight the A, B, and C with the same colors I just used. Purple for A, green for my D, and pink for my C. Now, we always want to pay attention to if there's any signs in front of our A, B, or C. For example, if I had a negative in front of A, I would need to bring that negative down with my values. If it was like negative 5x squared, A would be negative 5. If we have a minus sign instead of a plus in front of B or C, that makes B and C negative. So if it was minus 3x, B would be negative 3, for example. So we always want to pay attention to signs when we bring those values down. And so once we have that, we'll write a step 2. Step 2, we're going to find the discriminant using A, B, and C. So find the discriminant, D-I-S-C-R-I-N-N-T. Highlight that. And let's do blue. We find the discriminant, we're using the numbers that we identified as A, B, and C, and we're plugging them into the discriminant formula. So I'm going to highlight D equals parentheses b squared minus 4 times a in parentheses times c in parentheses. And I'm going to try to keep my colors consistent. So I made B green. I'm going to make it green here. I made A purple. I'll make it purple here. C I made pink, so I'll make it pink here as well. Once you've found the discriminant, we use the rest of the quadratic formula and we plug in the number that we found for the discriminant. So we're going to write that here, that 3. Now we use the quadratic formula. Solve both x values. And I say both x values because we will always get 2 numbers for x.
We'll do the positive.
Yes, that's when we do the plus and minus, or plus or minus. That's how we get 2 numbers. So below here, we will write that quadratic formula. X equals negative parentheses b. Highlight that green because we're using the same b as before. Then we have the plus or minus. I'll do the plus in green and the minus in red just to help us remember that we are going to separate these at the end. So we have negative b plus or minus the square root of the discriminant. That's what we plug in under the square root. So I'll highlight that blue. Over 2 times a. Excuse the wrong color. I need to do purple. So in step 1, we're finding 3 values. In step 2, we plug in those 3 values. In step 3, we're still just plugging in 3 values. It's 3 numbers every time. Step 4, we will just say, write your answer as either say x equals number, comma, number, whatever those 2 number answers are. Or we can use the brackets, just like whenever we identify the zeros or the x-intercepts of a parabola. Number. These are your options for how you write your answer. If you're worried you'll accidentally use parentheses, this is a good section to write a note that says, do not use parentheses. Big no. Don't do that.
Feel better about that.
Good. So this is a great note page to keep somewhere that you know exactly where it is. So I'm going to write on a sticky note on the end of it to make a little tab. And honestly, I'm going to cut my sticky note in half so I'm not covering half the page. Just so I have a little bit out. Let's see. If anybody does need scissors or anything, we have a bunch of scissors, I think, up at the front of the room on that bottom shelf. Or you can always borrow mine. I should have a bunch over here.
I'm just
Insert over here. Let's see. I think I've got some extras.
There's a pair of purple ones behind you.
What'd you say?
There's a pair of purple ones behind you.
Behind.
you.
Oh, you probably can't use these. Okay, there's clay all over.
We just use these.
This is
What you
my
doing?
play project.
Oh.
Don't worry about that.
Your mini hobbies.
Yeah. But up at the front of the room in that there's like a beige colored bin. I think the bottom bin there should be some scissors up there at the front if anybody wants them. But I am going to write here solve quadratic. That's a little tab there. So that way, when I close my notebook, this is sticking out and I can always find this page super easily. Definitely helps you stay organized. Okay. So I'm going to leave that up for a minute, make sure everybody has time to copy it down. Or if you think it might take you a little bit longer, take a picture of it. And we're going to move on and do a few problems in just a minute here. All right, so going to page 2, I am now going to give you some problems. We are going to look at some special cases that we haven't seen before. Or maybe we have. I'm not sure yet. Let me write our little title here. Algebra 2, Unit 2. Two for me. An example, let's see. Okay. So let's say I have, this is a special case. What if I have a problem that looks like this? I have negative 6x squared plus 23 equals 0. What's missing in this equation?
The B.
What is it, B or C that's missing?
B.
B. How do I know that B is missing?
Because there's supposed to be
Yeah, there's supposed to be a second term with an x. Our first term is negative 6x squared.
So your B will be 0?
Yes. Okay, if you didn't catch that, let's talk about it. Whenever I have a quadratic equation, I always have, remember, ax squared. So it's the ax squared plus bx plus c. So my a is the number next to my x squared. My b is always the number next to x. C has no variable. C is always just a number by itself. So that if there's no x, then there's no b. And the only number that would make x go away would be 0. If it was 1, if b was 1, there would still be an x there. It would be 1x. But if there's no x, then it's 0. So we can write it out like this. I'm going to say bx is missing. So b equals 0. It's important to know. So now that we know b is 0, let's go down the line and follow our 4 steps. Step 1 being to identify a, b, and c. So what are my values for a, b, and c?
A is negative 2.
Good. A is negative 6.
B is 0.
B is 0.
And C is positive 20.
Good. C is positive 23. Good. Okay. I'm going to get that other page flipped out so I can see my guide. I'm going to try to keep my colors the same. So A is purple. B green. And then C was pink. So step 1's done. We have identified A, B, and C. So peeking back at our guide from the last page, what is step 2?
Find the discriminant.
Find the discriminant. So that is what we're going to do. D equals. What do I write?
0 squared.
Yes, b squared. So 0 squared. Because b is 0.
Minus 4
Mm-hmm.
times negative 6 times negative 20.
Good.
I mean positive 20.
Good catch. So 0 was our b. A was negative 6. B was positive 23. discriminant. So now that I have my discriminant formula, my values are plugged into it. How am I solving for the discriminant here? What am I doing?
Divided by 2.
Divide by 2. We're not there yet. Right now we're just doing the discriminant. Just the b squared minus 4ac. Everything's plugged in.
Uh,
The zero
Zero.
cancels it out, so that's
Yes.
nothing. So you'll just do -4 and then the multiplication.
Yes. So the first thing we're going to do is that b squared, 0 squared. And 0 times 0 is 0. So we're just going to cross that out. So all that's left is -4 times -6 times 23.
Wow.
Go ahead.
552.
Yes, that's the number I got. 552. So my discriminant is positive 552. So, if you're wanting to label this and base it off of the last page, I'm going to write 1 next to my ABC and kind of circle that step here. Step 2 was finding the discriminant. So I'm going to write a 2 and circle all of this work here. This is all we did for step 2. Once we've done that second step, we've found our discriminant. What do we do in step 3?
Use the quadratic formula.
Yes, now we use the quadratic formula. So what am I writing?
-0 plus or minus
Mm-hmm.
square root of 552 all over 2 -6.
Okay, good. So I am writing, I'm going to put x equals -b, b is 0, plus or minus the square root of the discriminant, 552. Over 2 times a. And a is -6. Okay. All little arrows and things do that. Sometimes it's easy to forget where that 552 came from. It came from the discriminant. Okay. So, once all our numbers are plugged in, just like with our discriminant formula, we go just from left to right. And if there's anything on the bottom, we do that last. So, starting from the top left, what am I looking at first?
-1 times 0.
Yeah, -1 times 0. What is -1 times 0?
0.
It's 0. So you can bring down the 0 and write 0, or you could just cross it off. Just don't lose the plus and minus. I'll keep the 0 just for the sake of not getting confused about where it went. Let's see. I have -1 times 0, and that is at the next step. I'll bring that down. 0. Just going to highlight it so we can see where that came from. So I have 0. What comes down next?
Plus.
Good. Plus or minus. Now what?
552.
552. What am I doing with that?
You need to find the square root.
Yes. Find the square root. So, second x squared, get that square root on your screen. 552. Enter. And you're going to get a funky looking number.
Oh, it's crazy.
Yeah.
23 point.
So whenever you don't get a nice even number, that doesn't mean you did it wrong. You're going to get a lot of decimals with quadratics. We are going to try to keep as many decimals as we can until the very end. That doesn't mean I need to put all of them. I would just say at least put 3. At least put 3. So we have 23.4946. That would make this round up to 23.495. Okay. Is anyone confused about why I'm saying 495? 23.495 instead of 494. Does that make sense? It's okay if it doesn't. We can talk about rounding decimals.
Yeah, because I can't remember.
Okay, so let's talk about it. We'll do a quick little mini lesson. So on a little side note, I'm gonna write rounding decimals. If you know how to do this, then you get a quick little brain break. Rounding decimals. Could be a good refresher for you too, though. So if I have a number like, I'm gonna give you a random number, 12.58467. And I tell you I want 3 decimal places. I want 3 decimal places. I'm going to look at the first 3 numbers after the decimal. So the first 3 numbers after the decimal are 5, 8, 4. What helps us decide whether to keep the 4 at the end or to change it to 5 is the number that comes right after that, 6. If the number is 5 or higher, you will round up, meaning the 4 becomes a 5. If the number is 4 or lower, we round down and we keep it a 4. So, for 12.58467, what would my answer be if I want 3 decimal places? Do I round up or down? You round up. It would be 12.585. I'm rounding up because the number right after is 6. If it was a 4 or a 3 or a 2 or a 1 or a 0, we would keep that 4 instead of rounding up to 5.
Question, Miss.
Yes.
So when we do round the decimals, you want us to always do it 3 points past the decimal point?
I do like 3 decimal places. And now if it's off by like 0.1 or something, I'm not going to take points off. But it's a good practice because if any of you do move on to college or other things later on, they will want you to be able to round and have a specific number of decimal places. I'm not grading you on it, but it is good to know.
Yeah, because the math I was used to was the number right after the decimal point, where the 5 is. Like,
Yes.
If you round up or down because of the 8 right after that to make it 12.6.
Yes. So if I wanted 1 decimal place, you would round that up to 12.6. Yes. Perfect. Okay. Does that make a little more sense, you guys? That help?
Yeah.
Okay, good. So we have that square root of 552, we got 23.495. And so we're done with that. And what is left to bring down?
Divided by,
Negative 12.
Yes, 2 times -6, that is going to give us divided by -12. So we went from plugging the numbers into the formula. We simplified each of those 3 sections to get to here. And now I have 3 numbers with no symbols, just numbers with a plus and a minus. So what would I do now?
take 0 plus 23.495.
Uh-huh. Yes. Here's where we split into the plus or minus. So I'm going to do my plus right here. And that is 0 plus 23.495 divided by -12. And the other half that we split into is the same numbers, but with a minus sign instead. So 0 minus 23.495 divided by -12. And this is our last step. Once you've got your equations separated into the 2 plus or minus, whenever you feel like you know what to do next, tell me.
Then once you get the answer, divide by 12.
Yeah, we're going to get the answer. This is a special case because when I do 0 plus 23.495, it just stays 23.495. So really, I can cross that 0 off if I want and go ahead and divide 23.495 divided by -12. And what do we get? Let's see. 23.
I got negative. The same answer, but negative.
Yeah. Okay, so -1.95791666667. Or only 3 of them. Okay, so for your answer, you don't have to do all 3 decimal places if you don't want. You can. You can do 2 places. You can even do 1 place. I'm not as picky on your answer. Whenever you're doing your work and you're not simplified yet, it's better to keep more decimal places so that you get a more accurate answer. Sometimes if you don't include enough, your answer will be off by just a little bit. So for my answer here, I'm going to say -1 point, you could say 957.9, you could say 9.6, you could say 9.58. As long as you're keeping it pretty close to the right answer, don't round it all the way down to like -2. I want you to keep it -1.9. I'll go to 6. I'll keep 2 places. That's how we got that one. Now, how is the answer going to be different for the minus version?
It's gonna be a negative number.
Well, we had a positive divided by a negative for this one, so we got a negative answer. Now we have 0 minus that 23.495, which makes this -23.495. 0.495, right? And a negative divided by a negative is a positive. So weirdly enough, you're going to get the positive answer here. Now, this is one of those problems where you will get the same number, different signs. So if you mixed up a sign somewhere, you could still get the answer right. You could get a little lucky here. So let's see. I wonder if I can put a negative in front of that. Probably can't. Nope. 23.4955 -12. And we do get the exact same answer, but the positive version. So we get 1.96, and we will keep that. So that was all step 3 here. And in step 4, we just need to write our answer. So we've got those 2 options. I could write x equals my 2 numbers, negative 1.96, comma, positive 1.96. And that could be it. Or what's my other option?
Right.
The brackets. Yes. The little squigglies. Negative 1.96, comma, 1.96, no parentheses. Not allowed. Just brackets or x equals. And that is step 4. And we're done. We've done it. We've solved it. So just know if this was that special case where there was no number for x and there was not even an x, so that would make our b 0. Okay, that was kind of the major point of this problem. But being able to work it out to the end is very important too. Kind of zoom out so we can see it as a whole again. All right. You guys feel like writing out that little guide has helped? Okay, good, good. Good. I'll leave that up for a minute, let anybody finish writing if you need. Pause this. All right, so one more special case. This time, I'm going to go ahead and flip the page. And, right, that's day 11 notes continue. We're on page 3. So this next special case will say x squared plus 2x plus 1 equals 0. right off the bat, what is my value for A, B, and C?
1,
1 for A,
2,
2 for B,
and 1.
and 1 for C. Good. And we know A is 1 because there's still an x squared. That means the number in front of it, if there is not a number, that number is 1. One. So I have A, B, C. What do I do for step 2?
Put them in the formula.
Plug it into the formula. Which formula do I use first?
The D
Yes.
squared.
D, you had it right first time. D equals, we're doing discriminant first. D equals, and actually I'm sorry, you had it right the second time too. You said B squared, that's right. So D equals B squared. What goes there instead of B?
2.
2 squared, then what?
Plus
Look at your D equals. You have B squared. This one's not the,
2A.
this one's not the plus.
Minus 4.
Yeah.
Times
Yeah.
A times D.
Yes, we're using this formula here.
Yeah.
B squared minus 4AC. So 2 squared minus 4. A is 1. C is 1. So I'm going to highlight these because our numbers are the same for A and C. I'm going to show you that we're still using A and C. A, C.
Oh,
So now-
snapping of the highlighter.
Right. Okay, so I have my numbers plugged in to B squared minus 4AC. Now what? Yeah, 2 squared is 2 times 2, which is
4.
4. Good. So I'll bring down 4. Bring down D equals. Now what? Go ahead.
4
Minus 4.
times 1, which is still negative.
Yes. Negative 4 times 1 is just negative 4. That won't change it. So we bring down minus 4. It does. What's our discriminant? 0. So D equals 0 in this case. Now that's okay. That can happen. Highlight that in blue. Discriminant was blue. So step 1, we did ABC. Step 2, we found the discriminant. Step 3, what do I do?
The other formula.
Yes, the quadratic formula. X equals. What do I write?
Negative B squared.
Negative B. X equals negative B. Yep, that one.
Plus, minus.
Yes, plus or minus the square root of the discriminant, which is 0 all over 2A. Good. There we go. So, what goes in B and A?
2.
2 and 1. That song, it really does help.
2.
2a, which that will turn into 2 when you multiply it. So that's where the discriminant came from. And if it helps to draw arrows all the way here, you can do that too. Why not? Do whatever helps you remember. You don't have to draw all the arrows, you don't have to use colors, but if it helps you, do it. Okay. So, I've got my numbers plugged in. Now what?
When you do it, just solve it. Oh, you did the top part?
Yeah, let's do the top part.
Yeah.
-1, or just negative distributed into 2 times 2, what is this?
2.
It was 2, but now there's a negative. -2, yes. So, I'm going to bring that down. X equals -2. Then what comes down?
Plus a minus
Yeah, I got plus or minus.
0.
Yeah, the square root of 0 is just 0. We can type that in to make sure. I'll tell you that it is 0. Second, x squared, you get square root 0. Enter. It's just 0. So -2 plus or minus is 0. Then what?
Divided by 2.
Yes, 2 times 1 is 2, so we can just bring down divided by 2. And now we're at almost the last step here. Yes,
Okay, where'd you get that negative in front of the parentheses?
the negative outside of the parentheses here.
Yeah.
So this just comes from the quadratic formula. It's x equals -b. So the negative will always be right there after x equals. X equals -b. And we just plugged in b from our original ABC. So every single time you do this, you're going to start with x equals negative whatever b is. That makes sense. It should
I think I just forgot it on this one, so I
right here,
Yeah, I forgot it.
or on our actual like note page.
No,
Okay, so
the next one I forgot.
okay. So like for the
So
negative
that's-
0.
Yeah.
Gotcha. And luckily on this one, that negative didn't matter because 0 is 0. But on this one and every other problem, if you don't have that negative in front, your answer will be the wrong sign. You might get the right number still, but you won't have the right sign. So that's a good thing to remember. So now I simplified the -2 plus or minus 0 divided by 2. Where am I going at this point now? Splitting it into plus or minus. So first I'll do my plus. It's -2 plus 0 divided by 2. And my minus. Minus 0 divided by 2. Now let's look at the top of our plus. What is -2 plus 0?
-2.
It's -2. Bring over, divided by 2. And what is our answer here?
-1.
-1. So we've got one of our x's. Now let's look over here. What is -2 minus 0?
-2.
It's still -2. bring over the divided by 2 equals, what do we get? -1. Okay, so here's the special case. We got the same number with both splits. We got -1 both times. What does that mean? I'm going to show you.
X equals negative.
X equals -1.
Now you know it's something to it, girl.
Right.
You know it's something.
So if I'm looking at the fact that, remember how we talked about the x-intercepts on a parabola? What we solved for are those x-intercepts where it touches the x-axis. What just happened here is we got a graph where the parabola doesn't cross 2 spots on the x-axis. If this is -1, 2, -3, I'm going like 2 spaces per. Our parabola might look something like this. It only touches once on the x-axis. That can happen. So we only have one x value. There's only one x-intercept. And that happens. So the way that we could write our answer here is just x equals -1. Or our little bracket, -1. And that's it. If you get the same number both times, that means there's only one x-intercept. This is a special case.
All thanks to 0.
All thanks to 0.
Fill in the clutch.
Number. That's what this means. It means that our parabola only touches the x-axis once. And so that's our answer. X is -1. Oh, okay. Are you ready for your last exit ticket for the week?
Yeah.
Yeah? Okay. Okay. I will create that here. And I'll make some copies of it too. But of course, you're always welcome to copy it down as I write it. Before I start writing that, if anybody needs to see this, still go ahead and take a picture of it, or I can show it to you right after I give you the exit ticket. Or I move it though, does anybody need to see it? We good? Can I move it?
Yeah.
Okay. Go ahead and see. Oh, it's the last page in my notebook.
Oh,
What?
What?
I know. Well, I think I was using a notebook. I was trying to put all my notes in one book, and I didn't realize this was a used notebook already.
It was like no paper.
Yeah,
and you
I
messed
guess
up
I
your notes
like
every
ripped
one.
everything out. That's frustrating. Well, let me get a different notebook. If you are writing this one on your own, please, please, please write what day the exit ticket is. So I don't, when you turn stuff in and it doesn't have the day number, it makes it harder for me to figure out where it goes in the grade book. So this is the day 11 exit ticket. And this is your last one for this week. Due Friday, so not tomorrow, but then instead Friday, October 24th.
You have more paper for the day 9 exit ticket. Because I
Yes.
actually worked my workout on my exit ticket and I was like,
Yes, I have
Yes.
extras. I'll get you one here in just a second.
yeah.
Okay, so I want you to just again solve the quadratic equation. All values of x. Give you the one I wanted to today. Okay, there is your equation. This is your day 11 exit ticket. And I'm going to end our recording there. That's it for today. I'm going to run some copies. It is almost 11:40, so you still have a little over 15 minutes to work on this today. If you finish, you are free to leave as long as you turn it in before you go. And I will end that there and make you copies.